Hello, and welcome to section 3 of the first unit of this semester. All right, so moving on, continuing with exponents. So just a little review. If we had x to the fourth times x to the third, so we got the same base, what do we do with the exponents? We're just multiplying the two numbers. We add them, so hopefully that's what you're saying to yourself. So x to the 4 plus 3, so that would be x to the 7th. So if I was dividing them, dividing is the opposite of multiplying, right? What do you think I would do with the exponents? So when I multiply, I add them. So what do you think we're going to do when we divide them? Hopefully you are saying subtract, which would be correct. So that would be x to the 1. So that's what today's lesson is all about. So when we are dividing exponents, we're going to subtract them. So another way to say 2 to the 5th divided by 2 to the 2nd would be 2 to the 5 minus 2, which would be 2 to the 3rd. If you multiply 2 to the 3rd out, 2 times 2 times 2 is 8. And then the same thing on the next one. So 5 to the 6th divided by 5 to the 3rd would be 5 to the 6 minus 3, which is 5 to the 3rd, which would be 125. So that's what this little thing is saying. It's just saying what we just talked about when we're dividing two numbers that are the same base, that both have exponents. We subtract those exponents. So just some more examples of the same thing. So 2 to the 7 minus 2, which is 2 to the 5th, which would equal 32. Actually, this is the example I already did. So x to the 4 minus 3 would be x to the 1, or just x. In example 2, it gets a little trickier. So we have multiple variables. So I have d to the 4 and d to the 1. So that would be d to the 4 minus 1. And then e to the 3. Oh, excuse me. I need to do this 2 gets distributed to both the variables. So I should have d to the 4th times e to the 3rd divided by d squared e squared. So let's start that over. So now I have d to the 4th divided by d squared, so d to the 4 minus 2, e to the 3rd divided by e squared, so e to the 3 minus 2. So that would be d squared times e to the 1, or just e. And then the same thing on this last one. So I have 3 to the 5th divided by 3 to the 4th, so 3 to the 5 minus 4. 2 to the 4th divided by 2 squared, so 2 to the 4 minus 2. And then 4 to the 3rd divided by 4 to the 6th, so that would be 4 to the 3 minus 6. So that equals 3 to the 1 times 2 squared times 4 to the negative 3. So we do not want to leave an answer with a negative exponent. So I got to get rid of this negative 3. So 3 to the 1 is 3. 2 squared is 4. And then on the bottom, I'll have 4 to the positive 3. 3 times 4 is 12. 4 to the 3rd is 64. The main thing I want you to know is that we need to move this to the bottom. So let's see, 12 divided by 64, I can reduce that. They're both even. I know that 4 goes into both of these. Does anything else? I think that's it. So I think this would be 3 over 16. So we want to raise, okay, so if we have a fraction with an exponent, all the numbers inside of this fraction would get this exponent. So that's how we get a to the n divided by b to the n. And no more parentheses. So in example 3, if I want to simplify 4 divided by x squared all squared, So we have an exponent on the outside. So that means I'm going to have a 4 to the 2, or 4 squared, divided by x squared to the second power. 4 squared is 16. So x squared squared, or x to the 2 to the 2. So we got a 2 on the inside, 2 on the outside. So that means we're multiplying them, so x to the 4th. All right, so we talked about if we have a negative exponent, we got to move it. But what if our negative exponent is on the bottom already? So if it's on the bottom, I would just move it to the top and it becomes positive. So that's what we do here. So x to the negative 8, if I move that to the top, I'll end up with 1 times x to the 8, which is just x to the 8. So now we get into slightly more complicated things here. So whenever we have numbers on the numerator and the denominator of a fraction, I like to reduce those first. So what is a common factor of 4 and 12? So what number goes into both 4 and 12? So hopefully you're saying 4, but if you're not sure, they're both even, so you know 2 has to go into them. If I divide 4 by 4, or how many times does 4 go into 4? That would be 1. There we go. How many times does 4 go into 12? 3 times. Now there's a couple different ways we could do the variable with the exponent. So we could just do k to the 5 minus 10, which would be k to the negative 5. One thing I like to do though is I like to look. So since these are the same base, they're both k, which exponent is bigger, the top or the bottom? So as you can see, the bottom is bigger, so that means k is going to stay on the bottom. And then what is the difference between the two exponents? So 10 minus 5 would be 5. So next example, 2h divided by 16, h to the 4th. So the first thing I like to do is reduce the numbers. So 2 goes into both 2 and 16. How many times does 2 go into 2? Once. How many times does 2 go into 16? 16 divided by 2 would be 8. And then if there's no exponent on h, that means there's an imaginary 1 there. So which exponent for h is bigger, the top or the bottom? Obviously the bottom is bigger, so that means h is going to stay on the bottom. But what is the difference between the two exponents? 4 minus 1 is 3, so the answer would be 3. So 1 over 8 h to the 3rd. So example 5. So now we got even more things to deal with here. So first, before we do anything else, we need to deal with this. Well, we could simplify the numbers in here first. So notice that 3 and 15 both have a factor of 3. 3 goes into both of those numbers. How many times does 3 go into 3? Once. We still have that x to the 1/2. How many times does 3 go into 15? 5. 15 divided by 3 is 5. So that's going to make it a lot easier for us to apply this exponent now. So since we have a fraction in parentheses with an exponent, this exponent has to go to every single term inside of the parentheses. So I'll have 1 squared times x to the 1/2 squared divided by 5 squared. 1 squared is just 1, so that's going to go away because 1 times anything is just itself. On the bottom, on the denominator, I'm going to have 5 squared is 25. X to the 1/2 to the 2. So I got a 1/2 inside the parentheses and a 2 on the outside. So that means I'm multiplying those two things. So 1/2 times 2, or half of 2, would just be 1. So I'll have x to the 1 divided by 25. Now, you don't have to put the 1 here. It's probably better if you don't, actually, but I'm just putting that 1 there to see that I didn't forget to put an exponent. All right, so the next one. There's no numbers to simplify, so I'm going to go straight into the exponent. So every term inside of the parentheses gets the exponent. So I'll have a to the 2/5. Oops, wrong button. To the -3. b to the 6th to the -3. So one inside, one outside, that means I'm multiplying these two things. So 2/5 times -3/1. So that'd be -6/5. So I'll have a to the -6/5. And then 6 times -3 would be -18. So b to the -18 will be on the bottom. Again, we do not want to leave exponents negative. So if I have a negative exponent, I gotta move it. So I'm gonna move this to the bottom. This one's also negative, so I'm gonna move it to the top. Once I move those, they become positive. So b to the 18 over a to the 6/5. So I'm gonna show you another way to do these when you start off with a negative exponent. So first you can look at the two numbers. Those do not simplify, so I can't really do anything with them. If I wanted to get rid of this negative exponent right away, instead of multiplying like we did up here, instead of multiplying all those by -3, I could take the reciprocal of this fraction. So I'm going to move 5x to the top. 2x squared will move to the denominator. When I take the reciprocal, that changes the sign of the exponent. So now I have a +3. So if you don't like dealing with negatives, just take the reciprocal of this fraction, and this becomes a positive exponent. So then we do the same thing. So everything inside of the parentheses gets that exponent. So remember, don't forget the numbers. A lot of people forget those numbers. So 5 to the 3 times x to the 3 divided by 2 to the 3 times x squared to the 3. So 5 to the 3rd is 125. X cubed divided by 2 to the 3rd is 8. X squared to the 3rd power will be x to the 6th. So notice that we have x to the 3rd, x to the 6th. These two numbers, by the way, will not reduce, so I don't need to do anything with them. Which exponent is bigger for x, the top or the bottom? So hopefully you're saying the bottom. 6 is definitely bigger than 3, so that means x stays on the bottom. The difference between 6 and 3 is 3, so it'll have an exponent of 3. And that's our answer. And then finally the last one. So again, I'm going to flip this fraction first. So 2k will go to the top. 3j squared will move to the denominator. And now this becomes a positive exponent since I took the reciprocal. So this 4 goes to every single term. So I have 2 to the 4th times k to the 4th divided by 3 to the 4th times j squared to the 4th. So 2 to the 4th is 16 times k to the 4th. 3 to the 4th is 81. J squared to the 4th would be j to the 8th. 16 and 81 cannot reduce, they have no common factors, so that is the final answer.